is it so blurry? What's going on? Come on. Focus. Focus. Why can't I? Come on now. Focus. Fuck. Oh, that's really weird. Why won't my camera focus? Hmm. What the hell? I have no idea what's going on with that. Focus. Change channel level settings. I cannot get this thing right. I'll just have to be blurry. Let's see. Circular. This might be a good quick AI task. I'd like to do 3. That'd be nice. How many pins do I need to get the torque I want without shearing them? Oh, why not do it on screen? Should update. Hey, I have no idea what is going on with my camera, and I can't seem to change the settings while I'm live streaming. Whoa. That's weird. Nope, that's not what I want. I don't know why. It's totally fine if I'm up close. So annoying. It's okay, I'm ugly anyway. All right, let's see here. This is a 19 mil diameter, so it's extremely oversized. I am just, I think you joined after I moved away from the assembly. So I'm looking at this. It's basically a little housing for DU bushing for the through rod. And it also allows me to install this seal in the correct way, because it's pretty sensitive to how it's installed, and then close off. And I need to torque that into place. I don't need a lot of torque, especially for a 19 mil thread, but I would like to make sure it never comes out until I actually want it to. So I'm going to say 12 kilonewtons. M19 by, it's pretty, we'll call 1 by 2.5. Aluminum, aluminum thingy into housing with, what did I say, 12 kilonewtons of pre-tension. The threads will have light lubrication. How much torque do I need to apply, and how many, what did I go with? How many 3mm hardened steel pins do I need to make sure they don't shear? Boom. I have a calculator for this, because I've made many of these, but why not use AI, just see what it does. So I'll put 3 in there for now, and then do I have the right diameter for this? Nope, not at all. So I need a GGB catalog for DU bushing. How do you go about different ratios, or contact load variation, or you do go for? Oh, loaded question here. So I am a engineer first, and I have never tuned anyone's car. I have only worked on my own a little bit, not even that much, and I had advice from people at Penske at the time when I worked there, and that's just never been my focus. I'm strictly a damper designer, and now I need to get into, obviously, tuning. So that's been something I've been looking at quite a bit since January 2nd. And I've even hired a contractor who's a vehicle simulation engineer on an F1 team right now to build me a 14 degree of freedom model that is really, really good. He knows what he's doing. And I'm going to be progressing up from quarter car all the way to that, depending on the customer and what they want to do. But that will help guide me. I have been working with, well, not working with, but just having conversations with a couple of very experienced shock tuners. They have helped me out quite a bit on kind of how they approach it. They're engineers, or at least one of them is, I know, but they've been operating mostly off of what most shock technicians do, which is experience. Now, they certainly have a little bit more science to it, and they've shared some of that with me. some spreadsheets and things like that. But it's been a lot of just trial and error and documentation. So you know if you have a car that's similar coming down the road that you've done before, you can just look up what you've done before and whether or not the customer's happy, whether they've had maybe a lap record or a personal record or whatever. You want to be able to document that as a business to make sure your ideas are any good. How I'm going to approach it initially is definitely calculation based to some extent. So let me see if this is up. So this is a calculator I'm working on. It's not released yet, but it's general chassis setup calculator. And this page is really good for just setting up your spring rates, and then and that too. And then this starts to get into the damper tuning, so you can just play. Like, this will be publicly available at some point soon. You can play with damping ratios, and it will generate your curve for you in real time. It's kind of nice. Hard to see. Yeah, there you go. So it's pretty cool. And this again goes to just, there's a lot of philosophies on what damping ratios are appropriate for, and it really goes to every single car. It's going to be different. So front wheel drive, rear wheel drive, all wheel drive, where the mass is, how low you are, all of that stuff. What tires you have, or what tires you want to tune for, even if you change them for street and track. And ultimately, there's a lot of compromise. Unless you have a strictly dedicated track car and you're very consistent with your tires year to year, or at least between tunes, you're compromising a lot, no matter what you do. So it really boils down to some conversations you have to have with whoever's tuning the dampers around what you really want. And there's a lot of philosophies out there, and I would say you may be working with somebody that's really good, but you don't like the way the car handles, and you just have to find a different guy that has a different philosophy about how to do it. There's a lot of people who, and a lot of the aftermarket companies, they just mimic OEM tuning philosophies, which is not a lot of low speed damping at all. And that's kind of the opposite of the way I lean. I think you can, with the right damper, which means really low friction, really low rod force, and then more low speed damping, you're trading off some of that, it's dynamic force, but some of that force that you would get from high rod force and a lot of friction, you're trading that off for damping. So you need more damping to actually make that trade-off. Whereas, like, there's plenty of brands out there that openly advertise they want a shitload of rod force. They tend to have a lot of friction. So there's a lot of hysteresis built into that, and they think that's a good thing. I would never, ever say that or agree with that. There's nothing you could do to convince me of that. I've seen enough working at Penske to say that that's wrong, but they have their way, I have my way. And so, yeah, I'm in the camp of low speed damping ratios. Probably pretty digressive, but that's one area I want to play with a lot as I start to develop my personal car with my dampers that I'm designing right now, and get a better feel for what is a lot of digressivity versus what's a really good feeling high flow, and what scenarios does a high flow piston, linear piston work. Because the one thing that is true is, if you're going to have high low speed damping, you do need a little bit of digressivity, or it'll just be way too harsh in the higher speeds. But how much is enough? That's something I need to work on. So the way I'm going to handle that is I'm likely going to be doing a lot of free tuning. So if people are, initially my dampers will be pretty heavily discounted. That's the plan, at least, to just get product out there, get inventory in. It'll basically cover the cost and no profit at all, but it gets me going through the cycle of working with a new customer, talking through what they want, getting their feedback, and making changes. And I would do free rebuilds for those initial customers, just to start building that experience and get the process from new customer to happy customer, down where I'm going through that alignment on what those curves should look like, actually building those curves with my dampers, which are going to be very different than anything else out there, dynoing them, getting that data processed. So I could, depending on the customer, again, I want to collect as much information as I can about your vehicle. And whether you ask for it or not, I'll probably start building your vehicle into my simulation, whether it's quarter car, half car, or more complicated than that. And whether I'm sharing it with you or not, I'll be looking at that data from the simulation, because I need to start building up data in my database, just because I'm looking at long term. I want to do more machine learning model on, it's going to be pretty rough to make this work, but I want to be able to put my own feedback into the database with all the data and have, use some machine learning algorithms to then tell me, okay, for this new customer, this has worked before, you want to try this, and it'll literally just spit out a curve. And I obviously have to use my judgment on whether it's working well or not, and that's a good curve. But that's ultimately what I would like to be able to do. And then that curve feeds directly into the dyno software, and I literally just have to match it. And ultimately, that's the end goal of where I want to be. Yeah, hopefully that answered that. I need a GGB catalog here. Somewhat. Okay. If you wouldn't mind sharing, how are you calculating transmissibility with asymmetrical damping ratios? It's mathematically difficult. Oh, I haven't even looked at that. That's pure AI. That's not even, I don't even think it's calculating it right. Because I don't think the curve doesn't look right to me. So this is not available. It's not posted live or anything for anybody to use. I have not reviewed it at all. So it was actually totally abandoned, because I basically got no feedback on it when I shared a little bit about it. And then I just heard today that people that saw it were going to that person asking for it, but they weren't coming to me. So I had no idea people were actually interested in it. So I'm going to make it a priority once I get these designs out to go through it all and make sure it makes sense. AI will definitely give you garbage, that's for sure. No. Where is my note? There we go. GGB. Okay. This is These are metric. Yeah. So I need a 1410. 1410. There we go. $14.10, 16, 16.018. Is that right? Yeah. I'd rather show. There we go. Okay. Then we have a handy dandy thread calculator. I'm going to do a 19 by 125. 18,866. And the minor is 17 point. We'll call that. Now, let's see, when you say 14, is that a full dynamic sim or just virtual sim type situation? So it has, what it doesn't have is steering, and it's not, don't really need that because I don't have, like a crazy tire model, so that definitely becomes pretty important when you need steering. So this has tire, spring rate, and damping. Obviously, the damper, spring, and inerter per corner. Then it has heave, pitch, roll. What else does it have? Does it have anything else? It doesn't have any roll bar. I can easily add that, but I don't have that in there. I feel like I'm missing something. But yeah, it is. I think that's all the degrees of freedom. But it is. It'll do track replay. It will do. I have some. I actually have data from. Well, the contractor brought his data with him. That they're actual roads in the UK. So really good for like if I'm doing something for street cars. They're UK roads, so they're pretty rough, but I think that's a good thing. So that'll be good to look at that for street cars. And then it has he has the ability. I forget what website it is, but he has the ability to just download the track F1 track data, and I believe it's completely smooth, but it is the actual track. But again, there's no steering in the model yet, so it is what it is. And then what you do is you can just tell it an ISO road profile. So you pick your ISO level of that road profile to determine how bumpy it is, and it's just what's it called? like it's ISO level A, B, C, D, I think it is. And it's like a logarithmic, what's it called, random vibration. And then the magnitude of that will be how bumpy the road is, basically. The other thing, obviously, I can do, I'm working with a team that will be hopefully announced in the next, I don't know, maybe 2 months, that they've already given me track data. So I have that, which means when my EMMA dyno comes, I can play that track data on the dyno, but I can also play it in the simulation. And the whole point of that is that I can correlate the internal pressures of the actual damper running that track data to my hydraulic model, so that the hydraulic model performs exactly like their damper, and the inerter and the spring as well. I'll be pressure tapping all the areas around the damper to then adjust the parameters of the hydraulic model to match under the same scenarios. So it'll be ideally a almost perfect one-to-one. My simulation will mimic their track data. So I actually don't care about this in terms of tolerances. I care about this. And I need to look this up. Leave that there. I think that's pro. Yeah, I should do 10.1. We'll see. That's good. And this will be 60. Call it. We'll go with that. I'm going to go with that because it is slightly better on thermal expansion, which would actually keep the contact with the damper more consistent and control a little bit the friction at higher temperature. All right. Okay. And I need this guy to have the same thread. Where are we at here? 17779. Oh, that's not right. Where did you see me post this, or did you just see it on YouTube? That's what I want. Facebook. All right. And then 19 point. I'm gonna go with that. Push it a little. Okay. Forgot about that. This is going to have to be a bigger thread. Damn it. All right. I'll come back to that. I need to get the details on that seal. Let's see. Okay. All right. Here's my thread. Well, that's going to have to change anyway. Did I make this? No. 48.1. 48.1. I should have no problem coming in. Ooh, actually. Hmm. 3 mil radial area. That's okay. Where do I want to go with this? Hmm. One and a half. Might have to change that later, but I'm going to go with that. So that's M48 by 1.5. Now let's see. Is that what you're using? Oh, hold on. Severely overdamped. I don't need to revalve them. I have a clean chance of torsional stiffness. I don't have any idea what to actually aim for. I would. Have you driven on it already? So you know what it feels like, at least, and how it performs. So you've never driven on the dampers. No. Okay. So you want to at least have a basic calculator to um, look at your damping ratios and generate a curve from that. And then from there, you can just target ratios. And I would say, and obviously document where your starting point is, and maybe don't change anything. Go drive on it. It's not a bad idea, even if it is um, completely wrong for what you're doing, which I'm sure it is. I would go drive on it, get a feel for it, try and really understand. Which this is obviously the hard part, especially for non-professional drivers. Is what is the damper actually doing? What are you actually feeling? Is that the damper? Is it something else? Um, and then you can start looking at, okay, so that's I feel this way about it, and these low speed corners are under really aggressive braking, or I think it's got way too much pitch, not enough pitch control under acceleration or braking. And is that a spring problem? Like, always start with the springs. So you need to hone in on what your rates you're happy with first, and then start looking at whether or not the damper can make improvements to the setup after that. Then you have your baseline, which is whatever the dampers are set at right now, and document it just sucks in these types of corners. It sucks on high speed braking or whatever it is, and then you can start making educated decisions. So if it's not, if you feel like your low speed um, control is just really bad, then you know that you need to increase your damping ratio in the low speed region. The one thing I drove the FSE car back in the day, and the one thing that was I never really knew how to handle, which I think it's generally probably not even important for the types of courses. Well, I shouldn't say that. It's probably important when you go to practice at a real, and I'm talking about high speed damping. When you go to a real autocross, like an SCCA event, where it is actually can be quite bumpy, but in Michigan or wherever you're going, it's usually super smooth, like really, really smooth, where you really don't even have to worry about high speed damping and whatever it ends up being. So the other thing I would also start looking at is map and this is just something that I'm going to be doing. I think it's going to be very valuable, especially year to year. As the next team changes the suspension, you change your motion ratio, you have different CGs, all that stuff, and these cars are hypersensitive to that. I remember that. They are very small, very stiff generally if you do it right, and they will respond very, very well to any change you make. So year to year, any of those changes will your damping curve should change as well. And what I know it makes a lot of sense. I don't see a lot of people doing it though, but transferring your damper curve from your end spring rate, obviously, from your damper to the wheel. And then you can look at start really thinking about damping at the wheel with spring rate, so that you can it's easier for you to wrap your head around when the vehicle changes. What direction do you need to go, and how much do you need to change? Because when you go to the wheel, it really eliminates, you're eliminating that motion ratio. You're eliminating a lot of your what's the word? It's your not commonizing, but you're just aligning data that is not as sensitive to the specific vehicle. It's more sensitive to just the tire, essentially. That's my advice. But yeah, does your damper have a low speed adjuster at all? Four ways. Are these Öhlins? What model are they? Actually, Öhlins, they don't make bike dampers. Cane Creek. Yeah, I don't know anything about them. So I assume the low speeds are just whatever their needle shape is, and it's just two individual bleed needles. Yeah, that's what I'm designing right now. Same thing. Yeah. So what that means is you actually have a shitload of authority to make changes without really getting the damper into a very poor state in terms of pressure balancing internally. So you won't drive yourself into some extreme adjustment range where you have a massive amount of hysteresis, because it's just not how that type of damper works to the same extent as a monotube, especially the high-speed dampers or high-speed adjusters. But yeah, you should have a decent amount of range associated with those adjusters. So I definitely would not just tear them down. I would definitely ride those and go through the full adjustment range and take a lot of good notes. And then after the fact, that's really going to tell you the direction to go. And then you really probably, the only thing you'd really want to do then is rebuild it to reset so that that curve you were happy with, that then becomes the middle of your adjustment range. And then go again, and maybe take, whichever way that range shifted, maybe you need to keep going a little bit just to get a feel for where it starts to get really bad. And that should get you in a really good place based on your own feel. And then I wouldn't even talk about tire wear, because you're probably not going to drive enough that it's going to matter. But yeah, I don't know anything about those dampers, so I don't know how much range you really expect per click or anything like that, or how sensitive it is. But spring preload of the base wheel. Yeah. That's a good. Again, I don't know anything about the damper. Maybe they suck. I don't know. But the architecture, the hydraulic architecture, I think is really good for you to start with, because of the range that should be available in that design for you to just play with the settings and get a feel for it. If you had a straight up monotube and you needed to, when you crank up a high speed adjuster in a monotube, you're really screwing with the pressure balancing to the point where it's not really doing what it's supposed to be doing, or what you expect it to be doing. Generates a boatload of hysteresis. Yeah. Hey, my camera focused. Look at that. What was I doing? I was looking up a calculator. Uh-oh. Can't remember what I was doing. I know I need to finish that thread. So let's see here. Max 47.50, so 0.118. Yes. Bingo bango. M48, 1.5. All right. I need to start looking at O-rings. Okay. All right, we're going to call this one ooh. You could see my file names and see the customer. Not good yet. Can't announce that. Let's see. This will be PR year. There we go. All right. I have a very thorough calculator. Where'd it go? Where's SolidWorks? What the hell? Okay. So I initially just roughed these in, and based on I, now I need to figure out what actually fits. So we'll leave that there. So 36, and then this I know that's going to be dictated by the tube, which is the tolerance on that is. I wonder if I have that in the model already. Nope. Shit. Yeah. Oh, where's that tube? There we go. It's gonna be so minus 0.03. That's tempting. 38. We'll go with this one for now. 36.01 and plus 0.25 and 0.02. So then I need that in this guy. So this is a piston, yeah. Nominal 36.01. It's not symmetric. 0.02, we'll call it. Hey, there's 3 people here. Welcome. I am going through detailed design while answering whatever questions I can. Yes. So then, this, I know I want to be 36.03 maybe. You can take a mathematical approach all you want. What I do know for a fact is once you go driving, it will not be perfect. Right? It can get you very close, but unless you have a very serious model that is validated, obviously you guys have tire data, which is great. You can get to, just having that tire data is so huge, you can get to a very accurate model. But if you are not confident in that, then you have to take a qualitative approach, while also you can be doing the simulation side, the mathematical approach, the physics-based stuff, first principles, get through all that at the same time to make sure that model is actually making sense. And then over time, the next setup, maybe you want to do a range setup, so you want to change the tire parameters to adjust for that type of condition. Rely on your simulation to tell you what to do, make changes. Does it work? Right? You can't just one shot that kind of thing. You have to develop that over years, really. Let's see, 3603. What are we at? 30. Yeah, that's not enough. 36.1. What am I doing? No, ID 35.95. 03. So for this particular seal, it's internal DP only seal, so I don't actually care that it seals perfectly. It will seal perfectly. It's just not critical that I'm not going to leak to the atmosphere and ruin somebody's day. I'm literally just separating high and low pressure internally. So what I probably want is very high gland fill, because any of that dithering in the groove will add to hysteresis. And then I don't want to cut it when I'm installing it. And the tube is going to be very thin. It's only about 1.5 mil wall thickness. And there's going to be a lead-in chamfer, so it'll at risk of being a little sharp and could cut it. So I want high gland fill, low squeeze is what I want. and obviously the extrusion gap. It's going to want to center with the O-ring, but ultimately the bore that the tube sits in, it's got to be super tight tolerance because of the stack up radially to make sure the chrome rod and the piston and the 2 DU bushings at both ends with the through rod are all really well aligned to get the best friction possible. So I'm going to do this minus 03 is fine. We do get some leeway with the piston wear band, which is O-ring back, so it's floating a little bit. So I don't need to go tighter than plus or minus 1 thou. And then my actual gap, 080 to 030, so 35.9. That's pretty good. Groove inner now. So start. Whoops. What am I doing? Totally backwards here. 34. And let's just get this closer. ID's 56. ID's 7. Too much. 25. 32. Getting there. Stretch is, that's pretty good actually. I think that's a winner. So then, compression. Oh, gotta make changes. Okay, so 20. Well, let's see. There we go. 20s. It's too much. 1.9. 14 minimum. 22 max. Yeah, push it. 31.7. I noticed your design focus heavily on how friction with certain physical behaviors make you notice with shocks that have a lot of friction. So friction and rod force, I hate both of them. Let's just start with any force that is present stationary, which is rod force and friction, that immediate or always in every case has to be overcome before your damper even starts working. So in my opinion, you want to minimize that at all times. Then with that, you have your hysteresis, obviously, which is a lag on performance, essentially. Especially like if you imagine to the extreme case where you have an O-ring that floats up 3 millimeters within a groove. Well, that's obviously a massive amount of lag. The O-ring would have the volume of oil in that diameter, that column to that O-ring diameter, would have to displace before you start generating any damping force, right? So you want to minimize anything that does that in order to maximize the performance of your damper. Now, friction is, it has a lot of effects on it's called secondary ride. I don't know if you know what that means, but one way to imagine it is if you're driving, and secondary ride is more like primary ride is what you feel when the chassis is moving and what the chassis is doing. Secondary ride is way more focused on what the wheel is actually doing. So one way you can vision or your mental model for that is if you're kind of on like a washboardy type road and you feel your calves jiggling, that's bad secondary ride. Just something that always stuck with me when I was riding around with vehicle dynamicists and trying to explain all the different things that they look for when they're evaluating dampers. But that's a way you can feel that the wheels are not actually or the dampers are not controlling your wheels well enough, where that sort of vibration is making it through the chassis and actually jiggling your calf muscles. And there's different types of vibrations that you can feel in your calves or in your butt or your back. It's pretty interesting. I was actually thinking of having one of those guys doing a podcast and going through everything he does when he's evaluating a car like that. But these guys are all, they do this for OEMs, so it's a little bit different in terms of what anybody that races would be looking for. But I think it's still super informative and not something that anybody really talks about online. But it also can give you that terminology to be able to discuss what dampers are doing a little bit more. Where are we? So, so we're at 21 to 13, and this is not an OEM. We're not racing at -40, so let's go -10, even though this car's going to be in Australia. I don't think they go below 40, but I'm talking Fahrenheit here, but do they freeze in Australia? I don't know. -10 to, 125, still good. So then 13.4 minimum, 17. I'd like that to be lower. Mm-hmm. Yeah, I'm okay with that. So super low compression on the minimum. That's random. We get windshield ice in the winter. I don't know what that means. Groove width. So now we have 3.1. 3.1. 90. 3.2. 3. Man, I'm so backwards right now. 3.05. 3.0. Yeah, I'm okay with that. 94. That's going to be tight. I could also go 0.1. Oh, the max is based on the nominal, which means max at 125 is going to be even higher. That's pretty high. 3.05. Yeah, there we go. Okay. 0.01 on the width is fine. Groove radii 0.13. Okay. So that means 0.13. Okay. It was 31.65. Oh, shit. It's more of a difference than I was expecting. 0.03. So to be fair to say, damper friction causes random micro tire contact load variation that could lower your steady state grip. Yeah, absolutely. Definitely. Oh, this isn't tall enough. Shit. Oh, that's not good. Fuck. Not good. Not good. Oh, shit. Oh. Come on, you little bastard. Fuck, that's not enough. I need to lower this whole surface. Shit. That's painful. Whoops. Oh, shit. There. Just half a mil. That should be all right. Ah. All right. OD is 36.65, which is right around there. Okay. Yeah, it's fine. It'll seal. That is 60.6 and 0.35. That's super annoying. It's totally backwards. What the fuck? I want that one. 0.6 should be the same. And 0.6, 0.35. Okay. Now we're the same on both ends. Save. And then that is a 124 O-ring. Nope. Yeah. There we go. Yes. Yes. Oh, I just forget what this is. 538. I'll have to know what the standard tool nose radius is for metric, because I doubt it's 0.381. Let's look that up. Oh, Claude finished. Tightening torque, blah, blah, blah. 21 Newton meters. Yeah, I doubt it. Per pin, well, 62s. More than enough. Shear area. 3 pins, 120, 25 mil bolt circle. Pin material, yes, that's obvious. Did it figure out if the aluminum would fail? It did. You stupid AI. What about What was I doing? Oh yeah, tool nose radius. What is the standard metric mill tool nose radius? A lot of years of designing shit and not knowing this. Oh, they round up to 0.4. Okay, that's fine. 0.4 it is. Yeah. Was that enough for the chamfer? Yes. Okay. So that makes one O-ring. This is inner tube. The next one will be, I don't know. Oh, I'm not ready for that one. Oh, this piston seal. Rename. Piston ID. So that is roughly 14 millimeters. Yeah. Piston. Whoops. This is a. It's not a piston seal in a piston. It's a rod seal. So that's rod outer is 14. Bore inner is 8.1, I'll say. And then see where we end up here. 17. Okay. Wow, that's pretty big. Now I need to go down to 25, 20, 70. Stretch. Oh, what am I doing? 13, okay. So there's a little bit of stretch. And then this will probably be too much. Yeah, that's annoying to install. And again, this is sealing pressure across the piston, so it's not catastrophic for leakage. Oh shit, totally forgot about this. So this is going to be the bore of the inner tube. Both of them are aluminum. Aluminium 2.3 versus 2.36. Yes. 2.2 so that's not 2.3. This one, yeah, they're both going to be closer to 2.36, which is 6061. Okay. And we lost our min stretch. Shit. That's annoying. $31.7, $31.8. Damn it. CTE got me. I gotta redo this. 31. Okay. Oh, good. I can make this smaller. 0.7 to 0.02. So 2 is fine. So, no, that's not good. I gotta make this bigger. Shit. 3. Oh, that's annoying. $50,000 matters, I swear. 50,000, 50 micron. Okay, so it's a 124 O-ring, which is still what I have. 124. And 3 point. Oh, why do I have that already? I made a mistake earlier that worked out in my favor. 31.9. 31.9. Plus 0.03. 35.92 plus or minus 3. Oh God. Okay. We got our thread, we got our seal. That's good. Now, a rod, steel, gland is, that's a good one, yeah. So, back to this. So the rod is, what is the rod? Nope. Nope. There it is. 13984, 13966. 1398466 13.97. Is that a new question? That's a new question. Yeah, you're back. Have you seen those numbers that build effectively inertance by connecting a mass to the low speed? Yes. Do you know of anyone who has done anything like that for automotive use? To the low speed bleed assembly. So the damper that you're looking at on the screen is a hydromechanical inerter. I'm just hiding it right now. I don't know what you mean by connecting that mass to the low speed bleed assembly. So if that's true, I've never seen it. And I don't even think that would work, but I'm open to being wrong. Um, 984966. Go to. It's called Specialized Brain Shock. There's a cutaway on Google. All right, let's take a look. Specialized Brain Shock. Is this it? Float our brain. Brain fade adjust hose. The cutaways of the remote reservoir assembly that sits in the unspun mass. Okay. Innovator on cross control, manual lockout levers, internal inertia valve. My marketing lingo red flag is just waving real hard right now. All right. Valve resolution. Spring-backed brass weight and hydraulic damping system designed to react to forces encountered by the shock, controlling the flow of oil within shock internals. So this is a inertia valve. So yeah, it's not an inerter like I thought I understood your comment to be. I mean, inertia valve, it's something Penske had put some of those out for high-end customers, and they work pretty well as far as I'm aware. I never was the lead designer on any of that myself, but my understanding is they work pretty well. Whether or not theirs works, I don't know. Your question was what? Puts the needle out of there for chassis slows down. The needle is closed effectively. Switch out spring. Is the force varies based on? No, it's not like inertance at all. Based on acceleration rather than velocity. It's just a acceleration dependent valve. Is probably how I would describe that. And the energy that's dissipated is it is dissipating energy. It's not storing energy. The energy in the spring is just changing the performance of the valve, as opposed to the inertia actually storing energy at a rate relative to the acceleration rate of the ends of the damper. If it's an inertia valve, it's actually acting based on the acceleration of the valve itself relative to the rest of the world. So, like if you just take that shock without moving the ends of the dampers and just shake it, you should move that that mass on the spring, and that's not an inerter. It's cool. I like them. I think there's ways to utilize them that maybe aren't being done, or like this. I didn't even know they were doing that. Although I've heard of that in mountain bike shocks before. There's other ways. I think the interesting thing with some of these valves is everybody, well, really at this point, everything's been patented to hell. So it's really hard to find an edge. And you know, for good reason, most of the technology was focused for a while on what you do to the actual main piston, as opposed to being able to do things kind of around the main piston, like let's say you had a inertia valve, just totally making something up here. So like off-road trucks that have the reed valves in the tubes, so for positional damping, you could semi-actively or use an inertia valve to affect the performance of those position sensitive valves instead of the main piston. There's just like you can mess with anything, and I could imagine a world where there's your position sensitive valving. There could be a benefit based on the acceleration of the damper body. So you could have a inertia actuated position sensitive valve. And yeah, you can just go down rabbit holes like that. So patent pending. am I doing here? So I want to be, where do I want to be? What am I doing? The fucking rod, 984 to 966. Oh, that's not right. So I'm going to come 4 up. No. Opposite. 0.0. Oh, where was I? Was that 9? Yeah, 9. So 5. 13. Oh, what am I doing? 984 to 966. Oh, I'm making this so hard. No. Plus. Go away. There we go. Okay. Go 5. Yeah. There we go. Bore inner is wherever I want it to be. So 14.1 extrusion, yeah. 082 to 043. And the other aspect of this is centering the piston really well. So we'll go with 8. Yeah, that's fine. Then where are we at here? 25 to 19. So we can go 20 to 13. Yeah, that's pretty good. 112. And my gland fill now is pretty good. Okay. All right. I'll walk through this a little bit. So this is my attempt at making a through rod that is high volume production capable. Most through rods that I've seen have a thread or some sort of need for a protrusion above or larger diameter than the chrome. And what that eliminates is the possibility of a through feed centerless grinding on your chrome, which is unacceptable for high volume production. Ultimately, I want this company to be, to have contracts with small OEMs, maybe like Bugatti or, I don't know, you name it, Ferrari. I'll never get on Ferrari, but for different reasons other than capability. But that type of volume, I would still want to be able to process this efficiently, which means one of the aspects of that is that you would want your design to be through-fed, centerless ground for consistent quality and speed. So I've come up with this rebound stop and solid piston that thread together to sandwich the retaining ring. So then none of the rod is larger, no piece of the rod is larger than the chrome diameter. So this is a little challenging to get right, and the stress is through the roof in this area. So I got to deal with that still a little bit, but I think this will work really well. And now I will fix this groove. So this was, oh, not even close. 2.9. This is, 1404 plus or minus 04. Something. Yeah. Man, I feel like you're trolling me. You're not from Australia. That's a story I've shared at my day job now. Yes, I've definitely heard that. They used to have bladders that they would fill up. They'd put the car on the truck and then fill up a bladder underneath, and that would keep it from bouncing as it's just traveling on the truck. That has happened. I actually found the website where they sell those bladders before, and I think they're out of business. I don't think anybody does that anymore. I've never heard anybody say anything, talk about that ever. I swear you're somebody from ClearMotion. 18. Well, it's not going to help my stress problem. Oh, that's way too much. What's going on here? It's way too much squeeze or stretch. Definitely not, but maybe there are a few degrees of separation. Maybe someone from North Carolina. Yeah. Yeah, it's real, or was real at least. I don't know if they still do it. How did I miss this? My stretch is all effed up. Ooh, that's a big jump between 1 over shit. So that's a 12.37 to a 13. Holy shit! Sounds like I need a metric O-ring. That's calculated, and I think I can get the same size roughly. So if we went 13. And I don't think there's a 13.5. 13.9 is nothing. Is there a 13.5? The store, yeah. Where's metric? 70 dirham. Let's see. I was sizing to 2.6, and I don't need that at all. So let's do 2 mil. Shitload of options, so it's common. And so if we have a 2 mil cross section, and what was I saying? 13.5, that won't work anymore. That stretch is bad. Compression. Oops. Nine. There we go. That's not bad. Gland fill, so that comes down to 2.8. Nailed it. 0.4. So there's the rod. There's the extrusion. 17.2. 3.5% stretch. Reasonable compression. Okay. I shouldn't call this custom. It's off the shelf. Okay, so 2 mil. I kind of have to figure out if they actually have a 13.5. That'd be smart. Oh, shit. Nailed it. 89,000 in stock. I will buy them all. Might as well start building my order. All right, so then that's 17.2 plus or minus 0.3 and a 2.4. Nice. Get some material back. 72, 1405. Oh. And 0.1. And might as well put them in there now. So 0.25. Yes. And 0.13. Oh, right. What do you think about this? This has got to be boring as hell other than when you're asking questions. But that's why I'm doing it. I would love to have more people just to chat with while I'm living in my office, avoiding my family. That one. Yeah, might as well. And yeah, might as well. Oh, damn it. You're designing the FSE car right now? Oh, I should leave that as a chamfer. Faster to cut. Chamfer. Yeah. Those two. Do that. All right, O-ring number 2 done. Let's do copy. What are we doing next? Ah, small task. Oh, shit. I don't have a 13.5 mil O-ring modeled. Oh, nope. Do I have a metric O-ring? Commodity. Calculator. Oh, it's not in there. Ah. Oh no. That's one thing I was always able to avoid is carbon. I love the end result, but I don't want to do the work to get there. O-ring standard metric. Yeah. What do I have? Ooh. Okay. Da, 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 da. 2 by 13.5. And this is not in order. Look. I don't think that search is working. And that's why it's 2.0. I'm staring at 2.5. Is the search? Okay, search works. So 2.0 by 13 doesn't exist. Okay. Designing car parts. It's a dark art. Seriously, especially chassis guys. Designing the tub. Do you guys have you learned how to use something fancy like, I don't even think ANSYS is that, I don't know if they're well known for it, but simulation software that optimizes the layup orientation and then does the FEA? Yeah, I don't get the impression that that's the one most people use. Throw it right in here. Yeah. Very nice. Yeah, that is something that's. I wonder if I can. Well, obviously I can't, but I wonder. Well, actually, so how's the CNC plotter work? Is that like a roller that's CNC controlled, a rolling cutter kind of thing? I don't even know. Like a Cricut. What the fuck is a Cricut? Cricut. Smart. Yeah, I'm trying. Okay, I get that. I'm trying to picture what the actual tool shape is. Yeah. Okay. That's cool. Yeah. I'd love to do it, but I also don't want to do the work. But yeah, I get the latest stuff does make it a lot easier. Okay. Don't. I can't do that yet. I need to bring this fella into the rod. For transferring a horrible time. Yeah, for sure. F wet layup. I remember the guys on the team doing that just for the. I think they did more than one layer, but just the skin of the car. And then they would do, I don't know if you call them stressed panels. We called them stressed panels that honeycomb between two sheets that we then pulled the tubes together, glued it, and then let the tubes go, and you actually induce stress in the honeycomb wrapped carbon. It's not sheet, but whatever you call that. But yeah, they did that with wet layup back in the day, and that was painful to watch. Okay. Where'd my orange? Oh, there it is. Uno mille. Good enough. Ooh. Looks like more screws than it should be. 13 and a half. Oh, is that? No, that's right. Calculator doesn't lie. Something's not constrained. Oh shit, that's why. Oh fuck. I designed this thing in a way I didn't mean to. Oh well. There we go. So now that's constrained. Why is it that constrained? Oh, you son of a. What? There we go. Oh, jeez. What is happening? Piston band, O-ring, shaft. It's CAD is tricking me. Okay. There we go. Now everything's constrained correctly. This is good modeling practice. I hope you do it as well. Shit. What is that? Yes. Solid main. Okay. Uh-oh. Something shifted. What happened? You've seen people use mercury? That sounds crazy. Trying to think what the benefits of that are. Oh, you're talking about, sorry, you said fluid inverter. So you're talking about a helical flow path that I'm designing a hydromechanical inverter, which is it's essentially a gear generator. Obviously, no pump attached to it, but you have the weights attached to one of the gears. So the flow path through the gears spins the flywheels. So it's going to be traditional, pretty standard shock oil for now. I am going to be doing a oil comparison test, and I'll put that on YouTube and stuff. And I'll do before and after samples at the lab and see what they say about like how it broke down and stuff like that. And I have what's called Liquimolly already donated basically every weight that they make. And I want to reach out to Redline, or not Redline. It's called, I already spoke to them at PRI, Maxima, and I might do, it's going to be a lot of time, so I don't know if I'm going to do oils for like an Ohling's oil, because they're not going to tell me anything that's going to help my inerter, because their oil is not going to be so different from any normal shock oil. What I ultimately need to find out is if I need to do something other than a typical shock oil to enhance the performance of the inerter or get it to survive longer. I don't know if I'm going to end up with a boatload of cavitation at the pump that breaks the oil down too fast or something like that. So I'll be doing a shock oil shootout on the Emma Dyno at some point this summer with hopefully a whole bunch of donated oils, and that'll be fun. I got to make a plate. I got to have enough dampers, but I got to make a plate, and I'm going to do probably 4 up, maybe 6 up. So there'll be 6, hopefully, identical dampers running different oils at the same time on one dyno, and just beating the shit out of it, and hopefully get through that test quickly. Something shifted on me, and I don't know what. That is 387, 312. That looks right. Let's see. 744 is, that's 3.442, something like that. Too long now. And then got plenty of room there. There we go. 2 point. Yeah. The hell moved. Actually, that might work out well because I need to lower this anyway. That's too close. So if I could just take length out of this leg. Yeah, why don't we do that? Oh, why didn't that move? It's not mated correctly, that's why. That's going to fail. And now, yes. Boom. Okay. Now I got to fix that gap. Shaft bearing's in the right place, and at full rebound. I'm not thinking about this right. I did not solve it. Oh, go. I gotta go up, not down. I need to go down here, and then that feature needs to go up. Plenty of room here. I wouldn't say plenty of room, but pretty precisely machined components. Got the attention suspension set up for a drift car. Oh, car in question, Tuesday, swapped. Ooh, I like the sound of that. Absolutely none. I would like to get into that. I don't know what they need. I know everybody says they need as much grip as possible, but I don't know what that means for the way that they pitch the car around. So yeah. Yeah, I think it's the goal is the same. I just don't know how they actually achieve it with the way that they just throw the car around like that. Like, what are their wheel rates to begin with? Do they have extremely high wheel rates to help? That doesn't even make sense because that would hurt traction. Yeah, I can't answer that, but I would like to figure that out and hopefully work with somebody. Okay. Those are attached. Got a happy amount of clearance. And now we're too short. Yeah, GPT. Very dangerous. Best bet there would be to just ask it for sources. I wouldn't ask it for its opinion. So I'm going to go back up 2.5 mil, and then I need to affect something else. So this can come up 2.5 mil. That's a start. I don't think I want to do that though. 2.5 mil to there. Let's just see what happens. -2.5. Oh, that is terribly dimensioned. Yeah. All right. Okay, that puts us back to where I was. And that gap's still there. And that looks... Nope, that hasn't changed. And where are we here? Oops. Back to 744. Okay. So now, you can see I dimensioned that to the datum, but that doesn't work anymore. So I need the seal to come up. Oh, I never put this back. We're getting there. That's probably safe. That's a lot of space. Oh, I believe. Where am I here? Back to that. That's not great. I just need to move the piston, I think. That's bottomed. That's aligned. I think I need to move the piston. Why do I have to move the piston? What the hell did I change? So 744. What's the difference here? That's 133 and 744. So then I'm gonna do, yeah, 1 3. All right, it should be a little over 4. Oh, yeah, 4.3. Yeah, plenty of clearance. And yeah, oh, split it pretty evenly there. Okay. What next? Guess I should make an eyelet. And I should make this fit the new shaft. Hmm. 1 second here. Oh, shit. Oh, looking at my ugly mug. So somebody signed on and left. I'll share my screen in a minute. Work's calling me because work is in China. Oh. There we go. Yeah. Yep. And place with Oh my God. Where did I save it? Wrong place. Saved it in the wrong place. There we go. Okay. It's safe. Oh, what thread is on my rod? I don't remember. Oh yeah, it's a 1/2 inch. It is not M13. Or I didn't change it. 25 by 20. What is this thread calculator? Oh, this is, every engineer should have this. ME ThreadPal. Yeah. Oh no. I was wondering when this might happen. I think they went out of business. Oh, that sucks. Expired domain. ME ThreadPal. I've been using this for probably 15 years. Every company I've worked for, I made them buy it for me. It's so good. Because I always do custom threads for the stuff I typically do. It might be, maybe they just moved away or somebody bought them. I can put it in the chat, I guess. There we go. That site works for some reason. Different MRainy free servers. Highly recommended. Super cheap. The whole FSAE team should have them. My computer is lagging right now. Here we go. Yeah, 1/2 inch 20. Is that right? I just posted about this. I can't remember. I decided on it, I guess, and I didn't make the design change yet. What did I say? Oh, God. Here we go. All right. Oh, I did say 1/2 inch. Why would I go that small? It's pretty small. Certainly doable. Way dark in here. M20, 12. Do, 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 do. 12 by, or 1/2 by 13. Mm-hmm, 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 mm-hmm. Do, 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 do. So that's too big. I'd like to not do a custom thread on this. Do a modified M14. 14 by what is this? Oops. Yeah. So M14 is called M14 by 1. And then the major diameter is under 14. 13974 is not small enough to avoid the centerless grinding of the chrome. Right, that's 13966. 13.9. Yeah, so you'd have to do a max. You still have plenty of room there. Yeah, we're doing a modified thread, but it's still an M14 by 1. All go no. Well, I can't say all go no go gauges will work. It'll at least be a standard thread. Standard thread is M14 by 1 standard. Probably not. Probably a 1, 2, maybe. M14. Yep. 2. Oh no, there's 1.5. M14 by 1.5. We can do that. Yeah. Yeah. So this is where this is super valuable, because I will put the major diameter tolerance that I want from here onto the drawing. Obviously, you can figure all that out, but just having the ability to spit out literally any thread at all, any number you come up with, and it gives you all the specs. It is awesome. And this is actually cool too. If like a lot of times, if you do a thread with hard anodize, where you have real buildup that you need to account for, you can go to this coating window and add your pre-coat and your coating buildup, and it will provide the after coat, the actual inspection dimensions. So it's pretty awesome. Now, external, I could do. Nope, what am I doing? That's the pitch. That's not what I want. I don't really want that either. I'm just going to dial it back. So 13,966. So I'm going to make a max of 9. Max of 9. 13.9. Yeah. What is that median? 13.9 plus 13.732 to 13.698 and plus, or 816, and then plus 13.9, so 13 plus what am I? 13.732. There we go. All right. There's my special thread. Yes, this guy is minor diameter of 11 point. Yeah, getting that strength back. 11 point, we'll call it 8. Boom! That works. And yes, this is good. They can still roll the thread. That's what it was. I came up with a stupid custom thread, and the tooling that I'd have to pay for tooling to roll the thread, which is what I want to do. Now, even though I'm constraining the maximum major diameter, they can account for that and still use the standard M14 by 1.5 to roll the thread. So it will be a little less expensive for me than what I was doing. Awesome. And still have basically the strength of an M14, which is spectacular. Yeah. Now that is 12, 14 by 1.5, 6G rolled. Major is 13.9. I think you have to double check that mod. 13.90 to 13.72. Yeah, whatever. I gotta look that up. I'm pretty sure there's a specific format in ISO specs to how to write that. Okay. 1.5, 60. Now, I can fix this. Drawing's already made for this. That will be nice. Oh, drawing was made for this when I worked in the Freedom units. So that will have to get fixed. Yes, dimension. Remove. Okay. The minor diameter is going to be. Come on. What is. That's the one. I don't know why they don't give me the median, the mean minor diameter in this software. I don't need that. I just need. Not for drawing. forget what I put. 13.9 plus 732 divided by 2. There we go. Ba, 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 ba. My chamfers aren't big enough. Oh, what material? Of course, I closed it. 416. 416. I'll have to think about that. All right, that works. To work on that. Now the eyelet. Let's see. This one is quite a bit longer than the other one needs to be, so that's 55.58. Oh, it's not that much longer. 50.8. Ooh, I could use the same eyelet. Nope, I can't. That's a totally different diameter. All right. It's a silly problem. Let's do this one here. This already. So there's the handy dandy calculator. This is going to be called. I'm so used to day job active suspension called CP and VP, which is not what this is. Close. The fun part of making your own shit in a way that's never been done before. Well, I can't say never been done before. It's just a different design. I don't know what it's called. TBD. Think of something there. So I know I can't change this. $38.1. So that's 38.1, and I'll make up the rest. Um, 38.1. I'd like to go loose here to Make it easier, quote unquote cheaper. So 38.1, and then the bore would be 38 point, I don't know, 38 point. Yeah. Okay, and then 36, let's say. And, oh shit. This hopefully will be easy. Get this back to referencing the cells. Did that change? 17.12. Yes. Okay. 23. 31. This is another one that is just internal sealing. So I want low compression, high gland fill. Stretch is in the ballpark, so that's not enough stretch, so we'll go with that. And let's see. Oh, it's going to change a lot. 35. No, 36.5. 37. 37. Okay. Oh, what am I doing? Oh my god. 15 to 21. 33 point. That's pretty good. 33.8. Oh god. I've still got my chrome rod tolerance on here. 0.03. 3.85. Yeah, that's fine. Alright, so then that worked out all right. Oh, these O-rings are bigger than metric ones. I should probably use all metric, huh? Have better control over cross section. It's annoying how big this gland has to be. So big. Let's see. So this is going to be a 21.25. Actually, 20. Who's that look like? Yeah. Let's go back to the 20. Oh, 39? No. 34, 27, 33, yeah. So no compression is because this is 30. Let's go 35. Too much. 35. 35. Yeah, that's pretty good. Then that's a decent amount of stretch. That's the money shot right there. Glanville now 2.4. Nope. 3. Yeah, it's such a huge range. 8. For sure. Okay. Good stretch. Good extrusion gap. Reasonably high gland fill, although I'd like higher. And compression got a little high there. 35. How sensitive is this? Whew. Why is that fluctuating so much? It's more sensitive to the smaller diameter, smaller cross section. 35.4. Yeah, we'll go with that. Okay. No metric O-ring required. 2028. Oh. Two point 3. Oh my god. What the fuck are these settings? 38.1 plus or minus 0.06. Okay. And that's 35.4. .03. 0.25. Do 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 do. What is with these? Very nice. Yes. All right. Almost 1 in the morning. I should probably sign off and take a nap. Thank you to Spoon and Jonathan for joining and chatting.